Today we're going to be doing day 12, interpreting the remainder. This is honestly one of my favorite math activities because it's so real world, and it is something that you will totally run into in real life, even as a teacher, as a parent, as a friend, anything. You could use it now if you're trying to have, say, a birthday party. We'll use a birthday party for example. So say you have 48 people coming to your birthday party. Clearly it's going to be a big birthday party. So you have 48 people coming to your birthday party, and you need to figure out the table situation. And at the table situation, you can each table holds 5 people. So we're going to divide by 5. This is your total amount. This is number seats per table. And we are trying to figure out how many tables we need. So, I cannot tell you how excited I am for this lesson because it is truly realistic. It's something that will totally make you say or make sense to you once you look at it. So, say this is what the problem we're doing, and they want to know how many tables we need. So, I'm going to do the old-fashioned way. 5 divided by 48. Does 5 go into 4? It does not. So I can put a 0 here. Does 5 go into 48? It does. We need to figure out how many times. So I can write 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So, how many times does 5 go into 48 without going over? 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to put 9 here. 9 times 5 equals 45, so that's what I'm subtracting, and I get 3. I'm going to put remainder 3. So, if it said, we're going to put right here, whole tables full tables exact let's see, let me come back to the wordage for that. Well, here, let me change that to at seats at the last table. Okay, so if the question said there are 48 people going to a party and each table holds 5 seats, 5 people, and you cannot rearrange, you cannot shove 6 people at one table or 4 here, you have to have 5 people. If it said, how many tables do you need total, then that would be 10. Now, you are probably thinking, there's not a 10 here anywhere. Well, guess what? Remember, if it said in the contract you could not rearrange, you could not shove people into another table or whatnot, If we only bought 9 tables, then that means 3 people would be left out. Okay, so in order to fit all our guests, we need 10 tables. We have to round up. If it said, how many full tables are there? Then the answer would be 9. You would have 9 full tables. And then how many are at the last table? The answer would be 3. 3 people would be sitting at the last table. Now we know there would still be 2 more extra chairs, but if we said how many people were at that last chair, sitting at that last chair, or that last table, it would be 3, which we got from the remainder, okay? So, if they said how many people or how many full tables were there, there would be 9 full tables. How many people would be at the last table? 3. How many tables do you need total? You need 10 total, you need 10 total tables, because it's not fair to make your last 3 guests stand up. Now, I'm sure you're saying, yeah, I'd make so-and-so stand up. Well, we can't do that. We're talking about realistically, that's what we would need. So, this is considered rounding up. This is considered whole number only. And this is considered I guess you could say the fraction or your remainder only. We're going to do one more problem, okay, just to really explain it for you. Try to think of another scenario that would work for you, that you could understand this real life right now. Okay, the fair is coming to town soon. Say you're at the fair with 15 friends, and you are riding, let me put a little squiggly line, you are riding the ride with, say you're riding a ride that has two per row, okay, and say each row holds 2 people. Okay, so it's kind of like you're going to go 2 by 2. So it's not the swings. I don't know what it's called. Maybe the one that it's twisting you all around. Maybe chains or something, or what's it called, the zipper. So there's 15 friends total. That's including you. So this is number of people. And this is number per cart, cage, whatever you want to call it. So we know we're going to have to do a division problem. It's going to look like this: 2 divided by 15. Does 2 go into 1? No. Does 2 go into 15? Yes. 2, 4, 6, 8, 10, 12, 14, 16. So I know this is going to be 7. 7 times 2 equals 14. Remainder 1. My remainder comes from here because I have nothing else left to bring down. So, if it said how many people, let's see, how many carts total? How many carts total do you need? You would need 8. If you said 7, then that's not fair to that one person left over. Okay? Sorry, we only need 7 carts total. Somebody's going to get left out. If it said, how many full carts, the answer would be 7. How many full carts? So, once again, everyone is going to be able to have a full cart except for one person. And if you want to draw a picture, since these numbers are small, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So if you want to think about it, here's a cart, here's a cart, So there are all your carts. Okay, how many full carts are there? 1, 2, 3, 4, 5, 6, 7. There are 7 full carts. Now when it says how many carts total, you have to add this one because we still need that cart. Then if it said how many in the last cart, 1. Okay, that's our remainder. Now tomorrow we're going to be working on whole numbers only, rounding up, fraction or mixed number, decimal numbers, and remainder only. This would be considered rounding up. This would be considered whole numbers. This would be considered the remainder. Tomorrow we're going to work on fractions or mixed numbers and decimal numbers. Okay, so this is really what we're going to be focusing on. But for these two examples, sometimes you can't have a fraction or you can't have a decimal number from it. So I promise you this will help you in real life. Come with questions and come with examples tomorrow, because maybe I can call on you tomorrow and we can practice some of your problems you've thought up in your mind. Okay? Come with any questions you may have. Thanks so much.